All right, this is Cell Check 1.3. As a review, we have 10 minutes to solve 5 questions for an average of 2 minutes per question. So, number 1, we're given a list of values in a table, and we know that whenever we have a table or whenever we have only points, we can never find or we can never show and prove that we hit exactly what values in between them. That might make not a lot of sense right now, but let's go ahead and look at this question. So the minimum value of f on 0, 4 is 2. What do you guys think?
False.
False. It is false because we don't know what the minimum between 0 and 4 is. It could, for example, be a graph where it just looks like it's fine and it comes back down all of a sudden. We don't know exactly what it is because we're not... We don't ever know the minimum and maximum unless they give us a graph. So we know that one can exist. There's a theorem that proves that one will exist. What is that called? EVT. But until we have all the values, if we have a graph or a function, then we won't know for sure. So this one cannot be true. B, true or false?
False.
That one's false, and that's a similar reason to letter A. All right, can someone help me translate C? What does f of x is greater to 0? What does that mean?
The height of some point.
Careful here, because C means some point. So Kaylin said the height at some point.
The height of a certain point.
The height of all points. X means all points. I'll write this down here too. X is all points. And C is certain point. So this translates to the height at all points is greater than 0. And I kind of ran out of room here, but the height at all points is greater than 0, so is that true or false? The height at all points?
Oh, wait. Yeah.
Remember, it can dip down here like this. We don't know. It could suddenly dip down. So this cannot be... This is not... How do I say this correctly? It doesn't necessarily have to be true. It could be false. So that's why it's not true. Okay, so this D is translated a little bit differently. How do we translate this f prime of x is greater or less than 0?
The slope of all points.
Perfect, yeah. The slope of all points is what?
Less than 0.
Is less than 0, or another word is? What's negative, exactly. So the slope at all points is negative. And I'll write that down here. It doesn't match exactly with my notes, but the slope at all points is negative.
That's what that one's telling us.
Yeah. All right. This one is also false. There's only one theorem that guarantees slope. What is that theorem? MVT. We can only use MVT when it's differentiable, which it is, but the reason that it is not this case is what?
What? Wait.
So why can we not use MVT to show that this is always less than 0?
But it's open.
It's closed, it's differentiable, and for MVT we only need differentiable, so we can use MVT, but why does MVT not apply to D?
Well, because like it's kind of the same thing, like it could like dip down or something.
I don't know for sure.
Yeah, so you guys are definitely getting there. You don't know for sure. It could dip down. Those are all valid, and I would accept them. So the main thing to take away here is MVT only says that it exists at one point. This is saying for all points. There's no theorem that we can use to prove all points. So that one is also not true. So obviously the answer is E. Someone explain to us why it's E. Actually, before they even do that, we need someone to translate, and Kaylin's done the last 2 translations, so someone new. Someone translate f prime of C is equal to 0.
There exists a certain point,
A certain slope at 0.
Close. You have the slope part right, because f prime is slope. Slope of what?
Slope of 0.
No. Slope
all
of...
points.
No. C is...
Certain point.
C is a certain point, so slope at a certain point. But what is this slope of? What is this thing called? F prime. Remember all of the 4 definitions? F prime was one of the 4 definitions that we had in our notes. Or the other 3 definitions? Tangent line. Perfect. The slope of the tangent line, or the derivative, all of those work. So the slope of the tangent line at some point, and what is this last part? Okay, so what does the slope of 0 look like again? Show me with your hands or your arms. Exactly. Slope is like this. Yeah, so they're showing me with their arms right now. This is a slope of 0.
To figure that out, though, you'd kind of have to graph it a little bit, wouldn't you?
So there's only one theorem that guarantees slope, right? What is that theorem? MVT. Can we use MVT? Differentiable?
Yes.
Yes, because it's differentiable. Now, the last thing that we have to do for MVT is what? We have to calculate.
Use the formula.
Yeah, we have to calculate the average slope,
Oh.
or average rate. Yeah, you're right. It's not slope, but it's average rate.
Point.
And what is that formula for average rate?
F of B minus F of A over B minus A.
Carly has it. All right, so look at here. So we're talking between the interval of 4 and 0, or 0 to 4. So we're looking at these two y coordinates, 2 minus 2. So the numerator is going to be 2 minus 2. The denominator is going to be 4 minus 0. So the average rate is
0 over 4, which is 0.
0. Exactly. So, and look at what it's telling us here. It's telling at some point the slope of that tangent is 0. And that is true by MVT. Perfect. All right.
Wait. Oh, I did not. Wait, so F of B is. F of A and F of B is 2?
Yeah, they both happen to be 2 in the table.
Wait, how did you get to that? Wait, so you go to X is 0?
So f of a and f of b, what are a and b? A is 0 and b is 4 because of how it gives us the interval. If it gave us a different interval, it might not have been true.
Because I did it for D and I got a different answer, so I was really confused. But it's because it's. I got it.
Got it? Okay. I'm going on to the next slide. Are we ready?
Yeah.
I don't hear any screaming. All right.
What?
Number 2. So, what is this guy? Left-hand limit, right-hand limit, double-sided limit.
That's
Double-sided limit. What do we know about double-sided limit? There's
Left and right have to be equal.
sided limit. Left and right have to be equal. So the left, what that actually looks like in the notation is the limit as x approaches some point from the left has to be equal to the limit. Technically, I should have a function, limit of some function as x approaches c from the right. So that's the different way to mark them. You can either go this one or this one. All right, so we know that the left and the right are equal, and not only are they equal, they're equal to 7. So which of the following must be true? And we're looking at must be true. All right, f is continuous at x equals 3. What do you guys think? Thumbs up, thumbs down. True or false
I don't,
for number 1?
I don't think. Can we guarantee? I don't think we can guarantee that. Yeah, we don't know for sure.
Don't know for sure, so not true. And that's a good point, because let's look at this example graph. I'm coming up here, and then I have an empty, or I have a hole, and then I keep coming up. It's not continuous. Look, it's discontinuous, I guess is the word I'm looking for. Discontinuous at x equals 3, but the right limit, and the left limit are equal to the same point. They approach the same point. So not 1. Let's look at number 2. F is differentiable at x equals 3. What do you guys think? Do thumbs up, thumbs down. Everyone vote. I see 2 thumbs down, 3 thumbs down, all 4 thumbs down. Okay. And you guys are correct, because if it's not continuous, it's obviously not differentiable. Part of the definition of differentiable is that it's continuous. So not differentiable, I agree. What about number 3? F of 3 equals 7. Translate f of 3. What does that mean? F of 3 is
point or
f of 3.
Like a height of 3.
Height at 3, yeah. Not a height of 3.
Oh, the height.
It's a height of 7 at 3. So this is Height, height at x equals 3 is 7. That's how you translate that sentence.
Yeah, it's true.
This one is true. So do thumbs up, thumbs down. Let's hear. I see 2 thumbs up, 3, 4 thumbs up. You guys are incorrect.
We're what? What?
Look at this. So I just drew a graph here. What is the height at 3? You think it's also 7? Look, I can draw it down here at -1.
Fine. It's not. Oh.
We don't know because we could have a hole in the graph, where this height is either not existent, I don't even have a height, or it could be something that's not exactly in the center. Just because it's approaching, it's a double-sided limit, remember, that just means left equals right. It does not mean, it could mean, but it does not necessarily mean that it equals the point. It only needs these two. It needs left equals right.
So like,
Got it.
even, okay, so the limit is 7. So like, oh, because it could be, alright, never mind.
Got it.
Just stop.
All right, so number 2 is none. None of these.
It makes me feel like really self-conscious, like I get all of them wrong. And I just feel bad about myself.
We're learning here. This is good. All right. Number 2, fist of 5. How well do we understand the answer now?
We get it. What?
Fist of 5. 5 is I understand completely. 3 is not so much. 4 or 5, 4.5. All right. 4.5 was the average. Let's look at number 3. The graph of the function f is shown above. Which of the following statements must be false? So we're looking for something that must be false. So most of these are going to be true. So let's just do true or false next to all of these. F of a exists. Translate f of a again. Height at a. So I'll translate that here. Height at x equals a. So does a have a height? If I go straight at a, if I draw my wall, does it have a height?
Yes.
It does. It has a height of wherever that point is. So that is true. I'm going to do a capital T. So we're looking for something that's false. All right. F of x is defined for this interval. What do you guys think? True or false? Thumbs up, thumbs down.
False.
Defined means that if I go to any point, let's say I arbitrarily choose some point on the x-axis, I will have a height for it. Can I find a height for each point that I choose randomly for x?
Yes.
Yes. So this one is defined for all points. All right.
I thought it was because it was at 0.
So, what do you mean? That's
Can find a height.
yeah. Means you can find a height at every x in that interval. All right. C, f is not continuous at x equals a. Well, let's just answer the positive. Is x continuous? Or is the function continuous at x equals a?
No.
No, it's not. So it's not continuous. This is true. It's not continuous. I agree with that false statement, with the negative statement, I guess. All right. Let's look at D. The limit of f of x as x approaches a exists. So what does this thing mean? Someone help translate this. The left-hand limit, right-hand limit, double-sided limit
Double-sided limit
of the
X exists.
of the function exists. Yeah. So the double-sided limit of the function exists.
when you do come together to that one point.
So double-sided limit means what two things are equal?
Left and right.
Left and right. Are left and right equal?
Yes.
They are. They come to whatever this height is. So this does exist, so that's true. I'm doing a lowercase d. Let me do a capital T here. So obviously the answer is E because we've gotten all 4 true. This one is false. Someone explain why this one is false. What is this saying, really, before we even get to why it's false? What is this trying to state?
The limit of f prime.
F prime? I agree that's how you say F prime, but what is F prime?
Slope.
This is the
limit
slope.
of Slope exists.
Yeah, so it's saying that the slope of the left equals the slope of the right, instead of the height of the left equals the height of the right. This one was saying heights, left and right match. This one is saying slope of the left and right match.
Oh, you don't know that for sure.
We actually do know for sure that it does not exist because the slope of the left is positive and the slope of the right is negative. So they don't approach the same thing. They don't even come to 0. So this one is the false statement. The slope does not come together. The left and right part of the slope do not equal each other. Remember, double-sided limit as x approaches a without any positives or negatives means that the left and right need to be equal to each other. Left needs to equal right. And I have the notation all the way back here in, this slide. Limit as x approaches c from the negative side of f of x. That's how you say left. Are we good on 3? Fist of 5. We're good. 5, 3.5, 4. Where are we at? I see a 4.5. 5, 5, 4.
That was more of a
Okay. Let's look at number 4. All right, so we have an open interval now. So kind of key here. Open interval. It's differentiable. All right, and we have a bunch of values. This is kind of hard to see. Let's make a really quick sketch of the graph. F of 2 equals -5. So what is the coordinate pair of this guy right here? Coordinate pair. Where do I graph him?
2, -5.
2, -5. So 1, 2, -5. I'm going to say -5 is right there. -5, 2. All right, give me the coordinate pair for this second one.
5, 5.
5, 5. So I'm going to say 5 is right about there. 5 is right about there. And someone aside from Carly, someone new. What's our last coordinate pair? 9, -5. So here's 9. -5 is already graphed for us. So that's what our graph looks like. And we've seen him before in the homework too.
Nope, never.
Nope, never. All right. Which of the following must be true? We're looking for true things. So F has at least 2 zeros. What do you guys think? True or false? Thumbs up, thumbs down. Just looking at number
I
1.
don't get it when they say that. Like, what does that mean?
Ooh, what does that mean?
It
Yeah.
crosses the x-axis twice.
That's exactly, yeah. So Rosalie translated this. A 0 means it crosses the x-axis. So this means it crosses x-axis 2 times. So do we know that it crosses the x-axis 2 times?
Yeah.
We do. By what theorem?
EVT?
No, EVT guarantees maximum mins.
Oh.
IVT. IVT guarantees what? One word I'm looking for starts with an H.
Continue. Oh, what?
It guarantees what?
Crosses the x-axis.
Heights. Yes. Good job, Joy. Thank you. This IVT guarantees heights.
EVT is minimum, maximum. MVT is slope.
Exactly. MVT is slope. EVT minimum max. Okay. So this one is true. Number 2, the graph of F has at least one horizontal tangent. All right. What does horizontal tangent mean? Can we translate that into symbols? We know tangent. Tangent translates to. Okay, so horizontal means 0. But what does tangent mean? Do you remember what the word tangent means?
Tangent point. Or tangent slope.
Tangent slope, yeah, so it's the slope at some, it's the instantaneous slope, right? So this is really saying,
Oh, when you connect all the, or connect minimum to maximum.
no, you don't connect minimum to
Oh,
maximum,
it's
that's
like when-
average rate.
When we use that ruler, and like you would have to put a line that like shows.
Exactly, when we use a ruler to draw the line, that's tangent. That's exactly what we did. So, for example, if I had a graph that looked like this, right here, there's a horizontal tangent.
So there is one then.
So how do you know that there is one?
Because it's like up or out.
What is the slope of a horizontal tangent? The slope is equal to
0.
0. What is the only theorem that guarantees a slope? MVT. Can we use MVT? Are we allowed to have the conditions? We have differentiable, so yes. And then what's the last thing we have to check for MVT? MVT. First you need differentiable, which it is, and then you need to calculate what?
The average rate.
Average rate. And what is average rate again for the formula? Okay, let's do that. And a really quick shortcut is if you begin and end at the same point, the average rate is going to be. All right, girls. Average rate, if the beginning and end have the same height, because I'm connecting them with a straight line, the average rate is going to be 0. I know this is 0 just by looking at the graph. The start and end are at the same height, therefore the average rate is 0. So do I know that there's at least one horizontal tangent?
Yes. Well, I was right, but I
Wait,
was.
yeah, because I thought you
so
said
wrong.
you connect minimum max, but I guess it's not minimum max.
Oh, that's what you meant.
Yeah.
So you don't connect minimum and max because the max, you don't know what it is, but you do connect the start to the end.
Okay.
I think that's what you were trying to say, and
Yeah.
we had trouble getting there. But yes, you just connect minimum to the max. Or sorry, no, you don't do that. That's exactly what I said not to do. You connect the start to the end.
Oh my gosh.
You connect the start to the end, and that gives you the average rate. And the average rate helps for using MVT. So by MVT, this second one is true. The average slope is 0, and that 0 means that there's at least one horizontal tangent. Let's look at 3. Someone translate this whole thing.
So for some point from 2 to 5, that interval, the height of some point equals 3.
That was well said, yeah. Can you repeat it one time louder? See if the microphone can pick it up.
So for some point from 2 to 5, the height of some point is equal to 3.
Well said. I don't think I can improve that anyway. All right, so what do you guys think? True or false? True? True?
Yes, it goes from 2 to 5, so it must have to go through.
Ah, yeah, so it goes from, well, it doesn't go from 2 to 5. I mean, the interval goes from 2 to 5, but in that interval, it goes from the height of -5 to 5, so it's true by IVT. Yep, IVT guarantees height, so 1, 2, and 3. The correct answer here is E, and that rhymes. Questions on this slide before I move on?
We're good.
We're good? Okay. And we have the video to rely back on if we need it. All right, number 5. This one has a lot of translating to do. So we know that f is continuous, and we know it's a closed interval. We don't know if it's differentiable. So which of the following must be true? So we're looking for things that are true. All right, so I'm going to think. Okay, so everyone's going to have to volunteer at least once to translate. So if you see an easy one, go ahead and grab it. Someone translate A for me. Quiet raised hand.
I'll do it.
Okay, Rosalie.
There is a number point in the open interval AB such that the height of the point equals 0.
Yeah, the height at some point equals 0. So height at some point is 0. All right, do we know that for true, or do we know that for sure? For true?
That would be IVT.
It would be IVT if we had a set of points where we knew it had to go through
But we
the
don't
x-axis.
know for sure.
All right, we don't know for sure because it could look like this graph, or it could look like this graph. We don't know where it goes through. So this one is false, not A. All right, a new person, translate this part right here, this last line. In the open interval, what does this mean?
Oh, okay. The height of the minimum is less than the height of some point, which is less than the maximum.
Close. So you're seeing that the less than, and you see the f of c, and you're translating that as min and max. But that's not necessarily true. Min and max need a less than or equal to. So it's not min or max. So try again with a translation.
Oh, the starting point
So
is less than.
the height of the starting point.
Or the height of the starting point is less than the height of some point, which is less than the height of the ending point.
So you did a good job. Try and translate that. I'm going to translate it even better. So it's saying that the height at some point is exactly the height at some point is greater than the height of the beginning, and it has to be less than the beginning. So what that means is if I have a graph, and this is I'm doing for B right now, and maybe I said the same thing that Kaylin did, but generally the idea is if I have a point here and I have a point here, the height here and the height here, I'm saying that there's one point in between here that has to be less than this point, so it has to be under here and it has to be above here. Is that always true?
Yeah.
Most.
Well, we don't know for sure.
Okay, Joy, can you repeat that? It can't be equal. That's the critical part here. Because look, I'll give you guys a counterexample. Ready? Here's a graph. And there's a function. Do you agree that's a function?
Yeah.
All right. So the height here, so it has to be lower than this point and higher than this point for some point in between here.
Because we don't know what the starting point and ending point are, so.
Exactly. We don't know the starting height or the ending height, or the point for that matter, like you said. So we don't know if it is not equal to. This, in this case, in this function, it has to be equal to, but because there's no equal sign in here, this one is not always true. So it's not a must be. So this one is also false. And that's a hard one to see because there's only a few counterexamples that you can create. The counterexample is a constant function. Give me a fist of 5 on b. Do you guys understand why a constant function makes b false? Do you guys understand fist of 5? If you don't understand, give me a 1. It's okay. Okay, I see a 2.
Is one good or bad?
1 is bad. 5 is I have perfect understanding. Okay, so there's not very much understanding. So this statement is saying that the height in between these x values, so in this interval, the height has to be lower than the starting and wait, so I'm saying that wrong, aren't I? The height has to be I've been saying this backwards, but it's still the same thing. It has to be in between. The height has to be in between these heights. This height is not in between these heights. It is exactly equal to these heights. There's no equal sign. It didn't let us equal it. It has to be between it without equaling it. So it can't be true in this constant function case. So this is not a must be true. This is a might be. And because we're doing a must be, this one is not true. We're not looking for B.
And it wouldn't forget, like it wouldn't go above or below. But like we don't know what the starting is. So like it could be something like okay.
Let's look at C. Someone translate this part right here for me. Someone new. There are 5 people in here, which means all 5 people have to talk. How do I translate this? This translates to one word.
Height of MC is greater than or equal to the function of x.
Yeah, it's close. So I agree that this is the height at C, and you can say the height at some point is greater than or equal to the height at all points. But this translates to one easy word, and it has 3 letters.
Minimum.
It's using EVT again, and what does EVT prove?
Max.
Max or min. Yeah, so this translates to max. This whole thing translates to max. All right, so there is a max on this interval. Is that true? Is that a must or a might? Everyone.
Might.
Why is it a might and not a must?
We don't know. They didn't give us a graph.
It's a must
This one is a must
because it's closed.
because it's closed and because...
I'm so sick of this too. I don't get it.
Okay, so if you have a continuous and a closed function, you can use what theorem?
EVT.
EVT. And EVT guarantees there must be
A maximum.
a max and min. And this is saying there exists at least a max, at least one max in the interval. That's a pretty broad statement. I think there's one max in there.
Yeah.
And this is a true. There must be true, and that's proven by EVT.
We don't need to go through the rest. We already know the answer.
Let's just quickly go through them. I'll go through them, and then we'll start the next one. There's a number C in the open interval. This is saying that the slope is equal to 0. We could use this one, MVT, if it was differentiable, which it's not, and if we had the average rate, which was 0, which we don't know. So there's 2 things that we don't know, so this one cannot be true. Or it might be true, it might not be true. This is a might. And then last one, this is saying the exact same thing of MVT, so that the slope of the tangent at some point is equal to the average rate of change. That could be true, but we don't know because we don't know if it's differentiable or not. We need differentiable in order to use MVT. So I'm going to do MVT and I'm going to cross it out because we don't know if we can use it because for both of these, differentiable, I don't know. All right, and that's going to end the video.